All right, so let's do dilations now. So remember what I told you guys. Remember scale factor? Whoops. Remember how I told you that scale factor will always be new over old. And this is why it's going to come in handy. Okay, so the triangle ACE is a dilation image of triangle ABD. So if AEC is the new triangle, how do we know that? Because it's the image. The image is the new one. Tell whether the dilation is an enlargement or a reduction. So did it get bigger or smaller? Well, this blue obviously is bigger. The ADC is bigger than the ADB, right? I'm trying to like trace it without actually tracing it. Okay? So the blue one's bigger, so it enlarged, it got bigger. The triangle went from smaller, this ADB, to bigger, this AEC. Okay? So the scale factor is the new over old. So the length of side AC is 12. So this AC is 12. So if I'm going to compare to find the scale factor, I'm going to compare the larger side, which is 12, to what? 9. Because you see how this AC is corresponding to this AB. So 12 over 9, which simplified is just 4 over 3. Okay? Let's do another one. So the blue or pink, the pink figure is a dilation image of the black figure. Okay, so that means this is the new one. So this is the new one. This was the old one. So what happened? It got smaller. It was reduced. So now let's just find the side length of a blue one, whichever one you guys want. Do you want to do this one? Look, this is 1. So new over old. What is the corresponding side length to this guy? This guy. So 1, 2, 3. 1 over 3. You could have also chosen to do these bottom two. 1, 2 over 1, 2, 3, 4, 5, 6. Which is just what? 1 over 3 as well. Okay? So now, once again, the blue image is the dilation image. So this blue one's the new one. So from this big image to this smaller one, it was obviously a reduction. So now new over old. So 1, 2, 3 over 1, 2, 3, 4, 5, 6, which is just what? 1/2. 1/2. Okay? So a dilation has a center 0, 0. Find the image of point L. So the image of point L, so that means we want to find the image. So we want to find L prime. So my L is 3, -5. I want to find the L prime with a scale factor of 3. So that means I'm going to multiply the x. I'm going to multiply the x and multiply the y by 3. So what's going to be my L prime? What's 3 times 3? 9. What is -5 times 3? -15. That's it. So translation, we had to add and subtract things, right? Like add 3 or subtract 3. This, we just multiply 3, multiply 3. Whatever they give us as the scale factor, okay? So a dilation has a center of 0, 0. Find the image of point A. Find the image of point A. So if I have A, -5, 5, and I want to find my image of point A, I'm going to have to multiply by 1.8 times 1.8, which is just -9, 9. Okay? Now, what is this? Okay? Use the graph on the right. Find the vertices of the image of QRTW for a dilation with center 0, 0 and a scale factor of 7. So I'm just going to literally write my Q, W, Q, R, T, W. So my Q is what? -3, comma 4. My R is -2, comma -1. My T is 3, comma 1. And my W is 3, comma 5. So I need to multiply everything, the X by 7 and the Y by 7, just multiplying. So this will be -21, 28, -14, -7, 7, 14, 21, 7. And there we go. Look, all the answers match. Okay? So let's do this one. Draw the image of TBA for a dilation with center T. Okay, the center T means that this is not going to change. Just like the point of rotation, the point of dilation, so the T is not going to move from there. So that means my TB is going to get smaller by a third, my BA is going to get smaller by a third, and my TA is going to get smaller by a third. Okay, so let's see. So my B, remember, my T is not going to change at all. So I need to look for my B. What's my B? Oh, okay. So we're not going to be able to do it like that. Well, we could, but it'll be more complicated. The easier way to do it is that let's find So let's find this length right here. So we have, well, we really just have to find this TB is gonna get cut off by a third. So like, let's say my third, more or less, if this whole TB is this long measurement, let's find 1/3 of that. That's probably gonna be like over here. So my B prime is gonna be somewhere over here. And my A prime, 1, 2, 3. Okay, let's say it'll be over here. This will be my A prime, and my T prime is gonna be the same. So that means this is the new figure of my triangle. So I didn't even really have to like find the distance. I just did an estimate. So now, what is the figure? This looks nothing like what we have. And this, no way. This did a whole rotation, no. So it's between this guy and this guy. This is way too long. This looks like it was 2/3. You see this A? It looks like it was 1, 2, 3, 2/3. And this looks like it was way too big. We wanted ours to be 1/3. So it needed to be here. And that image looks more closely to this one. So our answer is D. Okay? So last one. A picture of a family crest is 5.6 inches wide. The family needs a reduced copy. Okay? So they need a reduced copy. So that means the pre-image was 5.6. Pre. The family needs a reduced copy for the front page. The copy must fit in 2.3. So this is the image. And what does that mean? That this one's the new one and this one's the old one. What factor should be used on the copy machine to adjust the size of the picture of the crest? So we just literally have to do a scale factor. New over old. So 2.3 divided by 5.6, which is 2.3 divided by 5.6 is 0.4107. They want us to round to 2 decimal places, so it's going to be 0.41, which is our answer.